So, font bigger. Yeah, can the font be bigger though? I have bad eyesight. Yeah, that's perfect, thanks. All right, so today basically we're going to talk about how the brain can help us learn things and process information unconsciously. So essentially this learning and processing is happening without conscious awareness. But first, before we get started with that, I think I'd like to start with an example. So in 1964, when Paul McCartney was writing the song Yesterday, he couldn't come up with lyrics, even though he already had a melody completely written. And he actually struggled with this, and he agonized over this for weeks, until one morning he woke up, and suddenly all of the verses were completely intact in his head, and he knew exactly how the song would go, and he was basically done with it. Now, this sort of eureka moment, I think, even though most of us don't write pop songs on a regular basis, I think it's something that we can all relate to. Imagine if you're buying a house or something, you're on the housing market, and maybe you're looking at different houses and you're comparing them to each other. And maybe one house is close to the university that you work at, and maybe another house is very spacious, and maybe another one has a great price. But it's not really a clear-cut decision, and you're not really sure which house to choose. Basically, when you're in this sort of situation, sometimes you might take a break and step back and do something unrelated to the problem that you're facing. So let's say you go to the movies for a few hours, and during this time you don't consciously think about the houses at all. You're just focused on the movie and that's it. And then maybe at the end of this, like when you're leaving the movie, the solution to the problem might pop into your head and you totally understand it and it completely makes sense, even though the last time you were thinking about the houses and working on them, you were still stuck. Basically, this sort of eureka moment seems to come up somewhere from our unconscious. That's what it feels like subjectively, at least. But it's not totally well understood where this actually comes from or how this happens at all. Now, yeah, there are actually a couple examples of this in science. For example, the physicist Otto Lowy discovered essentially his experiment that led to a Nobel Prize for discovering how neurons talk to each other and communicate. And this came to him in a dream. He had been working on the problem for several weeks, and he was stumped, and then suddenly it came to him, and he awoke, and it was all there for him, essentially. And there's actually an emerging literature about sleep and how sleep can lead to different kinds of creativity and insight. Essentially, even though these processes aren't well understood, it seems that something is going on here, and something is leading to these sort of spontaneous insights and these eureka moments. So, yeah, before we get into that, though, I think it would be helpful to sort of break down a little bit more what's happening during the learning process so that we can really talk about, in particular terms, what we're actually discussing here. So when learning happens, the first stage that occurs is essentially when we're first taking in information. So if we're reading something or watching something or listening to something, and we're essentially gathering information for the first time. So this is like Paul McCartney when he was originally writing the song, because as he was writing it, he was simultaneously learning the notes and everything for the first time. And this is something that cognitive scientists and neuroscientists call encoding. And then subsequent to encoding, sometime later, what happens is you need to recall that information that you've learned in order to use it, say, in a conversation or on a test or something. And this is like Paul McCartney waking up and having the lyrics suddenly in his head. And we call this retrieval. But the question that we're focused on today, and that a lot of scientists are currently working on, is what happens in between encoding and retrieval. What actually gets us between these two stages, and by extension, where do these eureka moments come from? And there's a traditional explanation of this called set shifting. And in set shifting, essentially the idea is that just returning to a problem that you were working on earlier allows you to look at it from a new perspective. Just because you're coming at it from a different angle, you were working on something else before, so you're just in a different frame of mind, or maybe even your mood is different. And all of these differences essentially can affect the way that you're looking at the problem. So that's the traditional explanation, but I'm going to offer an alternative hypothesis here, that the brain is actually performing an active task in between encoding and retrieval that actually gets us these eureka moments. So really the question that we're focused on today, and that I'm going to try to answer to some degree, is what is actually the brain doing in between these two stages. Now, at this point, I'd like to ask you all a question. If I were to give you information about different cars, say I gave attributes of these different cars to you, say one car is fast, and one car maybe is old, one car is a gas guzzler, and I just bombarded you with a bunch of pieces of information in random order, in not a systematic way. And then at some point later, I were to ask you to rate the different cars according to how good or how bad they are. Do you think that you would give me more accurate and more realistic ratings if I gave you time to consciously think about the cars for a few minutes? Or if instead of that, I distracted you for a few minutes and basically had you do like an unrelated number puzzle or something? So would you do better if you thought consciously or if you did something totally different? Let's get a show of hands. Who thinks that thinking consciously would be better? And this is not a trick question. So thinking consciously? All right, and then being distracted by something. Okay, so it looks like thinking consciously wins out, which is good because that's most people's intuition. But since the way I set it up, I think you can expect that the answer is actually that a distractor task, doing something totally unrelated, actually allows you to make better judgments down the road about the information you were presented. So as you can see here, participants, this is data from an experiment actually, participants who were given a distractor task actually have much more accurate ratings of these different cars, and they tend to basically have better judgments of which cars are good and which cars are bad compared to participants who got a chance to think consciously. And then there's also this middle condition here where participants just made basically an immediate decision. So right after they were given the information about the cars, immediately they rated the cars. So the fact that having done a distractor task allows better performance than even just making an immediate decision with no time in between, that really strongly suggests that something is going on in the brain that's active, that's allowing people to have a better understanding or a better comprehension of the information that people were presented with. But how can we actually test what's going on in the brain during this? Well, one way to do this, and the way that I've done this in the past, is using functional magnetic resonance imaging. So this is basically a brain imaging technique that allows you to see what's going on in different parts of the brain, what parts of the brain are active while people are performing different tasks. And basically what we did was we used the same experiment that I just described to you involving cars. We presented subjects with 4 different cars, information about 4 cars, and we gave them different attributes about this car. So like car A is fast, car B is slow, or whatever. Some of these attributes were positive and some of them were negative. So we presented subjects with this information, and then we had them complete a distractor task. This was just a number memory task that was completely unrelated to the cars. So they did that for a few minutes, and then we had them rate the cars according to how good or bad they were. And we structured the experiment in such a way that one of the cars was significantly better in quality than any of the other cars. So it had many more positive attributes than any of the other cars did. So since this car was objectively better, we could look at participants' ratings of this car in order to determine basically how well they learned and how well they understood the information that we presented to them. And so we had this condition, one of our experimental conditions, that involved the distractor task in between. Then we had another related condition where instead of a distractor task, people got to think consciously about the cars, like I mentioned before. Then we had a third condition in which people went straight from learning about the cars to rating the different cars. And just like the data that I showed you, it turned out that subjects who were distracted, who were given that unrelated number task, they performed much better in terms of making more accurate ratings. But that's not our main concern for this study, because what we were most interested in here was what the brain was actually doing during that middle period, during that distractor period, in order to produce these better ratings. And if you look at this, if we just look at the brain activity during the distractor task, do we see any problem of just using that to infer how the brain is getting from encoding to retrieval here? Well, yeah. People are doing a number task during this, and we're not interested per se in the brain activity related to the number task itself. So we had to find some way to eliminate that brain activity so that we were only left with that unconscious processing about the cars. And the way that we did that was we included a second number task that was identical to the first, except it was performed outside of any sort of car problem. So subjects just did this number task later on, and it was not preceded by any encoding of information about cars, and it wasn't followed by any ratings. So presumably there was no unconscious processing going on during this number task. So the brain activity that we saw during that was just the number task. So basically we could subtract that out from the original distractor period and just be left with the unconscious processing. So that's how we were essentially able to tease out that unconscious cognitive processing that was related to processing the different cars. So what did we find? Well, a number of areas showed up, which are a bit hard to see on the screen. But basically, one of the main areas that we found to be involved is this intermediate visual cortex. So this is in the back of the brain on both sides, so it's bilateral. And then we also found this, even harder to see, is lateral prefrontal cortex. So this is in the front right side of the brain. This is an area that's traditionally associated with control, executive function, meaning when people are focusing attention on something, this area is involved. So these are the areas that we found to be involved in this unconscious cognitive processing of the cars. Now, critically, we also looked at the brain activity during the encoding of the information about the cars. And we actually saw very similar activation. So we saw this intermediate visual cortex, and then this lateral prefrontal cortex. And in fact, the activation is so similar that if you overlay the images on top of one another, you can see that the activations actually match up really nicely. So it's the same neural regions, the same parts of the brain are involved in in encoding of the information of the cars and in the later unconscious processing which occurs during the distractor task. So this is a really interesting finding. Basically, when you're learning information, your brain is active and different parts of the brain are doing different things. But then afterwards, when you're doing something completely different, some of those parts of the brain stay active or they reactivate. And this is completely unconscious because these participants were just focused on the number task. They weren't aware that anything in their brain that was going on was related to cars. So because this was reactivation and it was unconscious, we call this unconscious neural reactivation. Now, given what we've learned here about this unconscious neural reactivation, we can update our schematic of learning here. So now we go from encoding to unconscious neural reactivation to retrieval. And I just want to emphasize again one more time, because I think this is, if there's one take-home message here, it's this, that the same parts of your brain are involved in this unconscious activity, like when you're going to the movies, as are involved when you're originally looking at the different houses and gathering information about them. The same parts of your brain are working. The only difference is that when you're originally encoding that information, everything is conscious. You're aware that you're reading information about houses. But then when you're at the movies, it's unconscious. You're focused on the movie, but your brain is still working on the house information. And I think that's really cool. Through other research on unconscious neural reactivation, we've learned some other things. There are interesting properties about it. For example, it tends to be most effective when it's processing complex information. So something like buying a house, that's a complex problem with a lot of different variables to consider. This unconscious neural reactivation really tends to help people learn and to understand these types of problems. But on the other hand, for a simple problem, like say buying a toothbrush, unconscious neural reactivation doesn't seem to help people make better decisions so much. So yeah, one part of unconscious neural reactivation is that it's it helps the most for complex problems, essentially. And then another thing that we've learned about unconscious neural reactivation is that there's a strong motivational component. So essentially, if a person does not have any motivation to learn or to understand something better, then this unconscious neural reactivation will not happen. So for example, if one of the houses that you were looking at got sold, then probably no more unconscious neural reactivation relating to that house would occur, because you have no reason to learn more about the house or to understand it better. Yeah, that sort of takes us back to the Paul McCartney example and the Otto Lowy example, the Nobel Prize winner. Both of them were dealing with very complex problems, and both of them were obviously extremely motivated to solve those problems. So those were conditions that were optimal for this unconscious neural reactivation to occur. Now, there are a whole lot of really interesting applications to for this research, but I think one of the most interesting concerns education. So yeah, basically a problem that I think a lot of teachers face at some point is that it's extremely difficult to teach students very complex and very, intractable concepts, very difficult problems, essentially. But I think that a lot of this research suggests that if students were given multiple short breaks during the course of learning these kinds of complex material, that this could actually create great performance benefits on tests and, more importantly, better understanding and better learning of the information. So what if when we're teaching children about the Civil War or something, we give them short, say, 5-minute water breaks, and then after they return from the water break, they get a short quiz about what they were just learning before they got their water break. Well, that short quiz would provide a motivation, a motive, to really understand the information that they were learning before the water break, and the water break itself would be an opportunity for unconscious neural reactivation to occur. So while students are consciously talking to their friends and getting water and whatnot, their brains would be unconsciously neurally reactivating this material. And if our laboratory experiments are any sort of guide, this would create a drastic performance benefit on the quizzes when compared with students who didn't get these short water breaks. So something to think about. Now, for a psychologist or a neuroscientist, I think the most interesting part of this research on unconscious neural reactivation is that it sort of has the potential to completely reshape how we understand and how we think about the whole process of learning information. And in addition to this, there are also, enormous implications for education and for related fields. I mean, insights from this research, I think, could help us give students the opportunity to learn complex information as well as possible. And I think that it goes without saying that would be of tremendous import. But a last take-home message for any aspiring rock stars out there is that if you want to write hit songs like Yesterday, that you should definitely take a lot of naps, and that you should continue to do the things that rock stars do when they're not writing songs. So thank you.